Hello, today we're going to be talking about the mediator design pattern, which could also be used like the component design pattern. It's really up to the user. This is a design pattern that I've only recently really started using, but I feel like it's useful for separating your code, especially when you're working in bigger groups. It's very useful for making sure that nobody is accidentally in the wrong section. And it's also useful for extending logic and making sure that some things can do different things or changing it up in the future. To begin, we're going to literally do everything from scratch in this project. We're going to set up our inputs, and then we're going to set up each of our things. So to set up inputs, and I'm going to do this very quickly, we're going to, and this is Unity 6 preview, we now actually start with an input actions by default. So what I'm going to do is just customize this to how I like to set up my inputs. In this case, I'm only going to do a few of them. I'm going to have something like this, where I have jump, attack, interact, look, or I don't have interact, but I have these four. I'm not going to read them all. But how I like to have them is this is a pass-through vector 2, this is a pass-through vector 2. The reason I like to do that is that way when you both press and release, it will function. And then an attack, I want attack to also be a button, but with pass-through button. So that way if I left click or if I let go, it'll function. And then over here, this will just be a regular old button. We can put initial state check on, so that way if you're holding space when you're in the pause menu, it's not going to cause issues. Great, so we have our inputs set up. The next thing that we want to do is generate a C# class. We probably want to move these as well, just that way they're in a nicer position, because it's a little bit weird right now. So let's create a folder, it's called scripts, and let's move them into here. Okay, and then in here, let's create another folder, it's called managers. Let's move both of these into our managers folder. In here, we're going to create a new monobehavior script that's going to be called player controls. Now what's important is the name of this file, input system underscore actions, which is just so atrociously named. I'm going to rename it quickly. So I'm going to uncheck this and press apply, rename it to player actions. Remember that, player actions, it's important. Let's delete this old one, and then let us regenerate our file. Okay, and let's open our code. Okay, so we have our script in here. What we're going to do is very straightforward. We're going to turn this into a utility file. This is because in Unity, our input actions actually do not depend on anything. They're very well designed, and they're actually just creating a new object. So what I'm going to do is I'm going to say player actions, and then let's call them actions. And then I'm going to use them. So I'm going to say public static void, and then initialize, or init for short. And then actions equals new player actions. Oh my gosh. Okay, there we go. Let's also create two more helper functions, public static void show or game state. And then let's make another one that's called UI state. And this is how I generally like to set up my controls. It's very modular and easy to use. It's accessible everywhere. And it will work correctly all of the time. Let's make two helper functions to aid with this. Let's have a private static void disable, or let's just make one for now, disable game. And that can be helpful for when we're working with our actual player controller. So in here, we have our actions equals new player actions, and we have an error. The error is because this is a static class, and everything made in a static class must also be static. So we have our private static actions over here. Great. So we can rename it so it's proper. Put this into our namespace, so that way it's all happy with us. And I'm going to go full screen so it's a little easier to read. The next thing that we want to do is we need to bind our controls and all the things we want to do, which is very straightforward. If you've never done this before, it's actions, dot, and then whatever thing you want to do, game, or player is the default name for it now, and then dot attack. I have another video on setting up actions, so I'll probably link that in the description if I remember. But we can say dot performed over here, and we can bind it to be whatever we need it to be. But we need to create a player object in order to bind it because, well, what's the point? So I'm going to go back into our scripts folder and create a new folder where I'm going to call it characters, but you can name it whatever you want. In here, I'm going to create the player script. I'm going to remove start and update for now, and we're going to add awake. Actually, I want start again. I changed my mind. So we have a we can start. Now let's move this into characters. Okay, and let's come back over here. So we want our player to do an action, so we definitely need a parameter. So I'm going to say player player, and we need to import the player action, so using characters. I'm going to ask my player to attack, and I'm going to pass down I forgot a step. We need to pass down our callback context, and then I can read the value as a button, like this. So what we've said here is when the player action for attacking is performed, we're going to bind and this is the observer pattern, but we'll talk about that later. We're going to bind CTX is a variable. It's a callback context, and it can just tell us what we did physically on our keyboard. Player.attack, and attack is the thing we're trying to do. We can attack. So I'm going to just press Alt-Enter and then generate method. So that's it. Attack has been created. Now, we need to do this for everything, and then I'll just show a quick little optimization thing. And I'd like to reiterate this. I'm not going to show these in the videos, these optimization things. They're exclusively for coming in the tutorial to actually see me and say hello. And I know it's an 8 AM tutorial and that can be hard. You can also watch the video, but I'm not going to talk a lot about optimizations, micro stuff like this. So we have all of our things. We have move, we have look, and we also have jump, right? For jump, we're just going to leave it blank. We want to assume when you have to press jump every time. Over here, when we look, let's pass down our read value as a vector2, because there's two directions you can look, right? And then the same thing when we move, because we want to be able to move forward, back, left, and right. So we're going to say ctx.readValue as a vector2, type of vector2. I'm not sure why it's giving me triangle brackets when I write vector2. I guess it's using system numerics, and that's probably messing with it. So let's import Unity engine, so it's not being strange. And then let's generate all of our functions. So just go back and forth and generate them all, pressing Alt-Enter to do it, or you can also just press on the light bulb. Okay, we've created all of our functions. Let's remove these because they're just going to throw errors. And this is now set up and ready to go. There's one more thing that we need to do just to make sure it's actually functional. In game state, let's just say actions dot and then enable, or actions.player.enable. Okay, and then UI state, or actually let's just finish this. We're also going to say over here we want to disable the UI, so only one of them's running at a time. Then over here we're going to say actions.ui.enable, and we're going to say disable game. Now when we disable the game, we're going to, I guess in here as well, we want to set our cursor.visible, or sorry, visible equals true, and our cursor, that's not right. We want it to be off. We want it to be false. And we want to set our cursor.lockState to locked. So that way it's locked, of course. And then over here, when we disable the game, and then we're also going to copy this and put it in here. Disable the controls. And we're going to put you to none and you to true. So we can see the mouse, can move anywhere, and it's disabled. Great. Now the next thing that we need to do is if we head back over to player, we have all of our functions. Let's talk about the actual mediator pattern here. And the idea is very straightforward. And you can do this in the component like style instead. The idea is instead of us, the player, being responsible for literally everything, making like a thousands of line code file, let us hand down our responsibility into different components that can be very specific. So this tries, or what I'm going to do is try to abide by the single responsibility principle that belongs to solid. So making our code more readable, and also the idea is if someone on Git needs to access a file, it's not everyone's in the player CS trying to access it, it's, hey, I need to access movement component. So what we're going to do is head back over to Unity, where we're going to create a new folder. So I'm going to put this in characters, and I'm going to call it components, but you can choose whatever you want to do. I'm going to create a few of them. I'm going to create the attacking component, or attack component. I'm going to create another that's called movement component. And I think for now that's fine. It gets the idea across. Back in characters into player, we're going to pass down our information. And first I need to get references to them. So let's just kind of work our way top down. First I need our reference to our thing. So I'm going to say private attack components. and then let's call it attack components. And then I need a private movement component. In awake, we need to bind them. Attack component equals get component of attack components. And then movement components equals get component of type movement component. In start, and the reason why they're different, or the reason why we need both of them, let's say player controls dot init. With this, we are the player, and then player controls dot enable game state. Now, the reason why we've separated them into awake and start is because in awake, we are saying these are things that we have direct access to. They should exist by default. It's stuff that belongs to us, and in start is stuff that could be exposed to other files. So generally, if I was going to access something from attack component, you'd probably want to do it in start instead of awake. But you could, because at this point you already have it, you know that it exists. Now, you're probably thinking, okay, why am I doing this? And I'll explain this again more when we get to singletons, the idea of things maybe not existing yet. So it's just good to have at least some idea of when you're using awake versus start instead of just, oh, awake happens first, I want to use awake. Okay, so what I'm going to do for attack is very straightforward. I'm just going to pass it down as a single line function, as the attack component should attack with the value as a button. And that's it. It's just the responsibility is no longer for me to deal with, it's for them to deal with. Movement component dot move, and then read value. And, you know, for a programmer, sometimes this can feel strange, right? Like, why am I going through this extra step to add code that's just going to do what I wanted to do anyways? And this also adds more complexity at times. It's like, okay, but now how do I tell other parts of my code that I'm grounded or whatever? It's really up to you how you choose to implement stuff. Like, this is merely a suggestion. It's a design pattern. It's how people have done things that can be used. So right now, this is the mediator pattern. And it's the mediator pattern because attack component has no idea that player exists. Okay, but if we wanted to make this into the component, wait, did I say? Sorry, if we want to make this into the component design pattern instead, firstly, let's move these into our namespace. Here. If we wanted to make this into the component design pattern, well, then we can pass down a reference of the player. So, like, again, really up to you how you want to do things. We can have an interface, which I guess for the sake of just showing you how that would look, let's add an interface here. Interface iComponent. And then we can say that we have our public void bind player. And then we can have our player. I don't like doing it this way. This is a way that you can do it. I don't like doing it this way because now it's very rigid. We're expecting a player, and you can't apply this to your AI classes. And that's another reason why splitting things up is a good idea, because you can apply them to your AI classes. So if we split this up, if we say bind player like this, not the best. There are ways we can do other things as well, but for now, let's just do this. So in here, all we would need to do is we could say iComponent, and then import it, and then we can store the player however we would need to store the player. So I'd be like this. And then I would bind it. So let's add an underscore to this one. Player. And now in player here, all of these functions or all of these components will have that capability. So if I said bind player, there you go. And this would just ensure and guarantee that it works correctly. Now, by doing the mediator pattern, and again, it really depends on how you're doing things, you can save a bit of CPU time, optionally, but it requires a lot more thought. This does not need to be monobehavior. Right now, or at least explicitly, it's not doing anything that would force it to be monobehavior. Like, there is no action in here that would necessarily need it to be monobehavior. But as soon as you want to do something like raycasting from your position, well then, yeah, it needs to be monobehavior. There's ways to get around things and to optimize your code, but keep in mind, whenever you attach a component, you're increasing search times for everything. It's not bad enough for its, like, you know, think about it super hard, but it is a consideration, especially if you want to like make the perfect thing. And it's also good to experiment and see what's working and what's not, right? So I'm going to delete iComponent because personally I do not like it. And I'm just going to do movement really quickly because it's super easy to do. So how I like to do movement, we're going to have fixed update, and then I'm going to have a rigid body that only we need to know about. The player doesn't care about the rigid body. They're not responsible for it. Only we are. So private rigid body RB. And then in awake, I'm going to access the rigid body. So over here, RB equals get component. And then in fixed update, RB add force acceleration. And this is lazy. It doesn't it doesn't quite factor in everything, but transform rotation multiplied by, and then the direction that we're trying to go. So this is, we'd create a vector up here. Vector 3, move direction. And then we can create another one, move speed. Well, let's serialize this one so we can actually access it. This one gets an underscore. Back down we go. So over here we do our move direction multiplied by our move speed. And this is going to have us move in the correct direction every time. So regardless of how the player's rotated, they're going to work. If you didn't know, when you rotate a quaternion into a vector, you get a vector that's rotated about that quaternion. So it'll be facing the same direction the player's moving. It's really, really awesome. So finally, the last thing we need to do is swizzle our read2 into our move direction. So I'm going to say move direction equals a new vector 2. And the word new is something that we're going to talk about as well. But we're going to say equals a new vector 3, read value dot x. And then we don't want to pass the y because then we'd start flying. We want this. That's the only one I care about for the sake of testing. I'm going to delete these because they're going to cause errors. And then let's give it a try. Now these are set up as mono behaviors, and we did get components. We do have to do get component because we are using rigid bodies. So I'm doing more of the component way of doing stuff rather than mediator. But at this point, our components don't even know that the player exists. It says player actions. Uh-oh. I committed a hate crime. I'm sorry, guys. This cannot be called... Oh. Player... Oh, wait. I might have just made it stupid. Okay. Right. Player actions is already the name of it, so let's call it actions. Oh, that's nice. It just automatically makes it. Okay. Let's come back over here and just change this to actions. Oh, and that reminds me, optimization thing. Over here, if you're in Writer, which is free for students, I strongly suggest it. If you're not using Writer, you're doing a silly. You can see that it's saying delegate allocation, new action callback instance creation capture of parameter player. It's a capture. So we are capturing a thing here that is being reused. Now, is this bad? Maybe, kind of. But the problem is, or the idea, what's really happening in the code is we're actually creating another player variable, a copy. I think it's a reference. We're creating a reference for each of these, so that way they're all pointing back to this one. So instead of having, you know, one variable that we're using temporarily, we're actually turning into 4 variables that we're using forever. Not good. So what we're going to do is we're going to say private static player, and then we're going to store our player. Sorry, that's stupid. My brain went full monkey mode. And then over here, we just replace it. And that's literally it. And instead of creating 4 pointers, we're just going to remember who our player is and we'll store a pointer directly to it. Right, at least that's the idea. And this is a very important thing, especially in C++, when it won't even tell you stuff like this. Ha 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 ha. Anyways, and there's one more thing that I want to mention is the word new. When you say new, you're allocating a new instance, and this is something to be careful of because this is literally how your RAM is being used. But you notice that in a movement component, I said new here, and it doesn't say anything. That's because it does not mean the same thing with structs, and this is nowhere near as expensive as saying new like this, which can actually be a source of your problems. So you want to be careful for the new keyword and when you're creating stuff. We'll talk more about this after midterms. Okay. Finally, let's create our cube. How I like to do things and how I think is the proper way to do things is when you create your object, and let's create another one so our cube has something to stand on. So we're going to create a 3D plane here. Move our cube up, and then over here we're going to right click and create an empty parent. Let's set the position to 0, 0, 0. It's arbitrary, and let's do so on our plane as well. Let's move our plane down a little. Okay, and then on our root object, we're going to add the player script. We're going to add a rigid body, and we're going to add all of our components. I'm going to move my components higher, and I'm going to give myself a speed of 1 just to show you this really does work. Okay, oh, the 1 is, I don't know why I said a speed of 1. I guess my brain isn't working. There we go, say 100. And you see it's a little bit strange, but that's because the rigid body is currently rotating us. So let's just freeze the rotation, and let's go it again. Oh, and I did it. Oh my goodness. Sometimes I call myself a programmer. Isn't that crazy? I don't know if I really qualify. There we go. You can see it works. You'll see that if I rotate the cube, we can still move in the correct direction when we move it. Very, very basic system, and we separated it up nicely, so anyone that needs to mess with the controls can easily mess with them without any interference. In my opinion, this is one of the best ways to set up your controls, especially when starting a new project.